Welcome to Ask and Learn.
Hey, welcome to the video for the water to be acceptable. The difference between the anions and cations should be lesser than 5%. And to calculate that, first we have to convert the concentration to milli-equivalent per liter, and for that we should divide the given concentration by the equivalent weight of the ions. Here the equivalent weight is calculated by dividing the molar mass by the number of electrons the element has lost, and by that the equivalent weight of calcium is 20, and from this we would get the converted concentration to be 2.22 milli-equivalent per liter. And for magnesium 2 plus, this would be equal to 15.5 divided by 12.15, and we would have it to be 1.27 milli-equivalent per liter. And for sodium, we would have it to be 13.8 divided by 23.0, and this would be equal to 0.6 milli-equivalent per liter. And for potassium, this would be equal to 7.8 divided by 39.09, 0.199 milli-equivalent per liter. And from this we have to calculate the sum of the cation concentration, and that would be equal to 4.28 milli-equivalent per liter. Following this, we do the same for the anions, where they are converted into their milli-equivalent weight concentration. So it would be, for carbonate, it would be the given concentration divided by its equivalent weight, and we would have it to be equal to 3.2 milli-equivalent per liter. For sulfate ion, we would have it to be equal to 33.1 divided by 48.0, which would be equal to 0.68 milli-equivalent per liter. And for chloride ion, this would be equal to 11.4 divided by 35.5, and this would be equal to 0.32 milli-equivalent per liter. And from this, the sum of the anion concentration is equal to 4.20 milli-equivalent per liter. And over here, the difference between the cation and anion is equal to 4.28 minus 4.20, and this would be equal to 0.08. And in order to calculate the percentage, we would have it to be equal to 0.08 divided by the total, that is 4.28 plus 4.20, that is the total amount of ions present, into 100. And from this we would have the percentage to be equal to 0.94%, which is less than 5%. Therefore, the water is acceptable. That is the analysis of water is acceptable. Hope the video was useful. Thank you.